Hey, we'll get started. Thanks for coming. We're really pleased to have today as our speaker Dr. Redden, who is chair of the Department of Biostatistics in the School of Public Health. Dr. Redden has had most of his formal education here in Alabama, I think, from Tuscaloosa for his PhD, and then the postdoctoral training here at UAB, and spent some time away from Birmingham before coming back in as a faculty member in the Department of Biostatistics, and then became chair. It probably seems like a couple of decades ago, but I think it's within the last couple of years. So Dr. Redden has been really one of the great spokespeople for disseminating fundamental information about biostatistical approaches to study design and data analysis throughout the community. If you haven't had a chance to go to his, I think it's 3-session sort of broad overview of fundamentals of biostatistics that has happened once a year for several years, that's a great thing. I really put in a strong recommendation for that. He has a few short videos that are introductions to other areas. Maybe he'll highlight those during the day-to-day. His own personal research interests have been very broad. He's had a particular, from my perspective, so I'm an immunologist, microbiologist. He's been very involved in studying tuberculosis, susceptibility, and therapy. He's worked in the cancer center. He's worked in the nutrition area. He's worked all over. So he's a sort of perfect biostatistician who can bring his skills to every level. So he's going to talk today about design and analysis of pilot studies. I just want to remind everybody that we have about a dozen people attending this from off campus who are connecting through the internet. I ask all of the off-site people to mute their microphones unless they want to ask a question. If you do want to ask a question, I think Dr. Redden will be pretty open to you just bursting in with a question. He'll try to take a couple of times during the hour and a bit to ask if you have questions. And if there are people here who have questions, I'll ask Dr. Redden to repeat them so that the people off-site can hear what's being asked. So thanks very much, David, as well.
Okay, so first I'm going to make sure that the volume's okay, because I naturally have a booming voice that goes down the hall, no problems. But one of the things is we are recording it, and we do want to be able to post this, so I'm wearing a mic, so I hope everyone can hear me well. If I am too loud, tell me. If I'm not loud enough, that's easily fixable. The other thing I would like to point out is several things. All of you will be, I have several references, small references, that I put throughout this talk. You'll be getting those by email. Don't be like, oh my gosh, you're going to bury me with stats articles. No. These are fundamental articles, easy reads, 2 to 3 pages, echoing exactly what I'm talking about here with regard to the nature of a pilot study. The other thing I like conversation. Everybody says, oh, he's a great lecturer. Actually, it's better at conversation. So as I go, if you have a question, just speak up. And you don't have to get my attention. You don't have to raise your hand. The whole purpose of this is to flow of information back and forth. So we're going to go through it, and this talk will probably be repeated multiple times a year. Even though it will be posted, I will also repeat it because there's something special about being able to have that one-on-one interaction, or that interaction you can't get from the computer. So we're going to go through the design and analysis of pilot studies. And what we do, and it's interesting, I'm not going to go very much into the analysis. I'm going to talk about how we go into the design. And you will notice the reason to do this talk is throughout the whole year, you pay a close attention to that barrage of emails that come in. You're going to see multiple opportunities throughout the year of different groups on campus advertising and putting out what I call a request for application, or the jargon is RFA, or a pilot study. And the reason I want to do the talk is very simple. I'm usually there at the front end. I'm there to help design it, but often I'm there to also review them. For the ones that I couldn't help design, I'm asked to offer an opinion. And sometimes part of this talk is designed to ground the idea of what's reasonable for a pilot, okay? And I'm going to talk to you about what often goes wrong in the design. Okay, you'll get the Bain et al. By email, but it's a small study, and this is done in preparation for a larger, more comprehensive study. Individuals who come to me and say, I want to design a pilot, the first question I ask them is not, okay, what's your specific aim? My first question is, okay, if you're doing a pilot study, where are you going to be in 3 years? What's the goal of the next 3 years? What are you trying to provide proof of principle for in order to go after an RO1 or go after a much larger funding mechanism? Because that's the purpose of a pilot study, is to give you preliminary evidence, preliminary data that makes the bigger application 1,000 times more solid and easier to review. I wasted some time playing on the internet. Most people do. Look at the free dictionary, and it's just a small scale experiment. You've got to make it tight, focused, to get a set of observations, and I love the way they say this, to decide how and whether to launch a full-scale investigation or a full-scale project. And that's the idea. Now, I'm going to go on and ruin it. And this is one of the things that happens in every talk I ever give. I just race ahead to tell you what happens in pilot studies is people do not control their ambition. They want to do so much. They spread themselves out so far that they do not actually get the essential pieces that are required to go to the next step. That's what you have to avoid. And the other thing you have to avoid is trying to slam the bigger project down into a budget that you never afford. There's always that temptation also. Okay? Almost all definitions emphasize small study, that is to proceed large. Now, I would hope that you're racing ahead and going, ooh, does that mean I can use some of my data from the small study and just kind of swing it up into the bigger study? Actually, there's a lot of statistical research into being able to build that efficiency in. If we're going to discuss when and under what conditions could we do that. Okay? Now, what I always worry about, especially when I start, and one of the things that UAB has taught me and taught me very well, one of the things that they didn't teach you in graduate school, is the need for clear, very well articulated specific aims. And usually I can spot confusion in pilot studies or pilot applications by just looking at their specific aims. I want you to remember the aim of a pilot study is not to demonstrate a difference between groups. That's too big for a pilot study. It is to demonstrate the feasibility of getting people into a study. It is to demonstrate you can actually record what you're promising you will be able to record in the bigger study, the next study. Like I said, it's to demonstrate the feasibility of key components, such as recruitment. We had a study over in the VA years ago where it was going to be a multi-site clinical trial. The biggest concern in the study section was, can you really get the patients? Are you going to be able to get these men to agree? The compromise was finally, if you're not willing to fund the multi-site clinical trial, will you be willing to fund a pilot study and give us 18 months to 24 months to prove we could get 1/3 of the total sample size in a pilot, showing them that we could get recruitment, we could get their consent, they would actually agree to randomization, and they would actually fill out the diaries that we were asking them to fill out. Government agreed to it, we did it. Then we turned around and used that data to say, now can we have the rest? And that's what we did. Okay? And the other thing is, this is the key thing. I have often joked when I teach inside the graduate school, the reason they keep me on this campus is I'm really good at writing a power calculation. If I didn't have that skill, I'm not certain they will. The key here is don't get confused. If you put a power calculation into a pilot grant, I'm going to walk across the street and say, what are you thinking? You're going beyond the scope of what can really be done in a pilot study. And this is debatable among statisticians. I'm being recorded, but that's okay. I'm always being recorded. I got an RFA last week from NIH saying that they wanted to do a pilot study with a power calculation. I read it. I was like, doesn't make sense. It doesn't make sense to me. And I just didn't understand why they included that. They needed to demonstrate feasibility. You can demonstrate feasibility without having to bring inferential statistical procedures. Now, to prove to you that I actually listen and read evaluations, if I ever use a term in here that you're not certain what I mean, interrupt immediately. Because that came out of a lecture about 7 months ago, or a talk I gave 7 months ago. 3 months later, I got the evaluations, and there was one right there. He said, and they said point blank, he used terms that I don't. That bothered me. So when I say inferential procedures, what I mean is going out and doing the two-step t-test, trying to do a regression. All of these things are usually premature in a pilot study. You can calculate the statistics, but they're going to be used for a later study to guide something. Okay? And that's what I know I'm rambling, but that's why I say to estimate key parameters. One of the things that's very important is that we need to, for a power calculation, we need to have that standard deviation. We need to know how variable the thing is. How noisy is it? That's all the standard deviation measures, is how noisy is it. If it's really noisy, going to need more. If it's really tight, I'm in great shape. But the pilot study can help you get a good estimate of that to begin with. Okay? Please understand a pilot study is not simply a repackaged version of a larger study, but with a reduced sample size you can afford. I've seen that before. I've reviewed many of them where they lay out this grandiose, I shouldn't say grandiose, a very ambitious project that's really the follow-up project. However, they know that they're not prepared to do it, so they'll come back and they say, we're going to do all of this for $60,000. So keep your aims tight. Keep them focused on demonstration, measurement, documentation, feasibility. That's the best approach to it. It's also, I hate this, but a lot of times people will say pilot study, just say it's a pilot study. If they can't achieve the sample size that they really want, and they want to do the study anyway, they're going to say it's a pilot study, but they've already included all the other inferential procedures. They're doing all the other things that it's just a little too early. Now, not to try to confuse you. The key thing, though, is in a pilot study, I'll write the analysis plan. I'll write the analysis plan of the future study. I'll say I'm going to do all these things. I'm just going to do a trial run on this data, but I'm not going to draw a conclusion. I'm just going to look at the information and use it to design the future one. Okay? So you're all going to get 3 short articles. I've got your emails. Y'all registered or you signed in. And I'm just going to email these 3. Like I said, if you don't want them, I understand. But if you're here and you're interested, these are very good reviews on how, what, why, and how of a pilot study. By the Bain, Lancaster, another recommendation for good practice. And the last one was good on the role of interpretation. And I think that's the key thing, the interpretation of a pilot study. The whole thing of a pilot study is you're going to avoid, I'm going to just say it right now, at the end of a pilot study, you should not be expecting to have a p-value. If you have a p-value there, it's probably premature. You should have an estimate of a correlation. You should have an estimate of a standard deviation. You might have a confidence interval, those types of things. You'll have a percent of people who completed the diary completely to help individuals or reviewers in the next phase understand. The study is working well. We are able to do what we're promising we will do now. Okay?
There are new things to this, and the people online are hearing someone is tapping on their keyboard.
Me?
They're remote listeners and they're talking.
Oh, I'm sorry.
No, I can hear. It's not you. It's not you. It's so if you'll excuse me for 1 second.
No problem.
They're all muted, and it looks like they're not. So I'm going to make sure that they are. I can't see them. There they are. There we go. Apologies for the interruption.
It's not an interruption. Perfectly fine.
There we go.
Thank you.
You're good. Thank you so much.
All right, so I'm sorry, I learn everything through comparison contrast. It's the best way for me to learn. It's the way I always do everything. I set up one example and compare it to the other to learn things. So I thought it would be a wise idea to say, this is what I would expect reasonable language for a pilot study to say. And these are the things that I think are reasonable language for the years of experience I have dealing with RO1s and larger studies. I'll point out something. We talk about to demonstrate feasibility of collecting the diary data. Especially, I don't know, I've done plenty of nutrition studies. Getting people to record what they eat is a little challenging. And often there's a lot of missing data in there. And we want to be able to demonstrate how clean that data can be if we use the correct protocol and correct training. To demonstrate the ability to recruit, I did this. The elderly people seem to enjoy it. They enjoyed their weight training. But we had some conviction. Would we be able to recruit them? Would they complete the training sessions? And then we could talk about just to estimate the adherence to in a given group to the medication. So notice the key words: demonstrate, estimate. I want you to keep that in mind. Pilot studies demonstrate, they estimate. Whereas for a larger grant, you're talking about to test, to conclude, sometimes to prove. I get nervous when people use the word prove around statistics. But these things are to actually do a formal testing of, a formal comparison of a pre, of a post, and to demonstrate that there has been a research impact. Okay? One's about demonstration and estimation, the other one is about actually conducting the scientific test to measure impact. Okay? To do that, you've got to have a larger sample size. That's the second stage. First stage is first demonstrate you can do it. All right? And like I said, do you see the difference? The pilot is a demonstrate. The pilot study is that can allow collection of data to guide, but it's always saying demonstrate or estimate. It is not saying, I get very concerned when I'm reviewing a pilot study and they say, we will test. You know what that tells me? Either they've made some very big assumptions about a massive effect. It would have to be a very humongous effect for us to be able to see it in a small sample size, or they've assumed a very small standard deviation. How can you assume either one of those until you have pilot data? But hypothesis testing, all these things you learned in stats class if you stayed awake. Where you did the two-sample t-test, the ANOVA, the regression, all of these things. That's actually down the road. You can think about it, you can say where you're going, but don't race ahead of it. You'll be able to do it in the pilot stage. Okay? If you ask me, after I'm going to age myself right now, 20 years of being at UAB, doing hundreds of RO1 designs, not as many pilot studies, but it's actually hard. It's at a university level, there's a great opportunity to get pilot studies. At NIH level, it's often harder to get a pilot study. But one of the things I have learned over and over, and you need to please understand this. If you can remember one thing out of this whole thing today, this is it. Ready? You lose on page, you win or lose on page 1. Period. That's the truth of any application you ever write, whether it's pilot or whether it's a much larger grant, because we expect to see the specific aims on that first page. The clearer they are, the more precise they are, and the more articulate and focused you are, the better off you are. So one of the things I often find frustrating when I have collaborated or consulted on the design of pilots is it's very broad. Oh, we're going to do something. That works. How about telling me exactly, and let's be focused. So emphasis here is don't think that a pilot study doesn't have aims. You need to stop before you do anything else and write the specific aims of that pilot study. And you know, I hate to say it, it's easier to write specific aims for a pilot than it is for a normal one. I mean that. Mainly because you have to ask one question. What must be demonstrated or refined? If I get a trial run, if I get a chance to make all my mistakes before I start, what mistakes do I want to make now? Before I'm on the big study. That's the way to think about it. What must be demonstrated or refined to make the larger trial more likely to succeed? You can focus on that, and sometimes it's a matter of demonstrating that this new technology does provide the level of measurement you want it to, or that it is as efficient or as accurate as you want it to be. These are the types of things I would emphasize over and over. Take the time to study the specific aims. I'm going to pause for a minute and ask if there are any questions. Because I also, the other trick I've learned over the years, always make eye contact. Because the eyes actually reveal who has questions. Thought there was a question in the audience. Any questions? Nope. All right, go ahead. So well-articulated aims are essential for a pilot study. And this is the other thing that I just kind of, we just finished a very large round of developing pilot studies for the CCTS. The other thing I emphasized in all the one-on-one collaborations with everyone that was trying to go through that process. The Achilles heel, remember, the two go together. The aims of a pilot study are to demonstrate or are essential foundations for the future study. If you don't describe a future study, you leave the reviewer hanging. You're going to do this to do what? So it's very important that I emphasize over and over, before you submit this, that last paragraph better be talking about, at the end of the pilot study, we will have the following things, and then we will be submitting the following application. That way they see the horizon all the way through. Here's the, when I'm going, like I said, I always raise a head. The lack of the fact that you almost have to be able to say, once I get there, I will be able to do it. But I do not have it today. And you have to live with that uncomfortable dynamic. Because we're in the application, you can talk about hypothesis testing in the future trial. And how all the stuff you're doing now will inform and guide the development of that. But the big frustrating issue that when I meet with people over pilots is they come back and they say to me over and over, but I need a power calculation. But I need a power calculation. Let me ask you a question. Why do you need a power calculation? What is a power calculation? Anybody? Going once? I know some of you, I could call you by name.
To do power calculations to see the effect size.
Okay,
Whatever measure you're looking at.
All right, now that's one way to phrase it. Use a key term, okay? Power calculations actually tell you the probability of being able to declare an effect size significant if it exists that if it exists, what's the probability of being able to, at the end of the study, what's the probability of being able to say, I've got statistically significant results if this effect exists? The catch here is it always ties to the hypothesis test. It ties to the hypothesis test over and over. And I warned you, don't expect to be doing hypothesis tests in a pilot study. Now, I'm going to go a little bit further and clarify. The reason we got the one in the VA is I designed that pilot study to say, we're going to do this. And at the end of designing and saying, it was actually a urinary incontinence study in men, veterans. There was concern that we would not be able to get the diaries, the diaries would not be clean, that they would not go all the way. We were going to do a 12-week study. Reviewers had said there's no way they're going to come back for that number of visits, so we ran the pilot, okay? And we designed the pilot. At the end of the pilot, the two things I put there, I put the power calculation for the future study, saying we can only on the pilot mechanism do 70 individuals. We acknowledge that. However, we are hoping, by demonstration of the feasibility of this, to, within 3 years, expand the study to 210, which will provide, and I'll make it very clear, here's the first piece, we want to demonstrate that, and then if we have met our benchmarks, and we don't mess with the design, we would go further. Okay? I'll clarify that comment in just a minute. But the key here is the power calculations associated with the future study, not with the one you're doing right. Make sense? Where have I lost you? Okay? Okay. So that comes to the question. Dr. Redden, data, how'd you pick 70? How'd you pick 70 when you went back into the NIH to get them to give you that pilot study? I picked that because I knew I could be able to, on 70, I would have a good chance of knowing if my assumptions for the power calculation were right or wrong. All I did was I said, okay, at 70, I'll be able to get a standard deviation. I'll be able to get a confidence interval for it. And I think that confidence interval will be able to be tight enough for me to be able to say either I'm way wrong or I'm close enough. And did you just hear what the statistician said? The power calculation needs to be close enough. True. Power calculations are always wrong because they start with the word assume. There are a bunch of assumptions, and what we have to do is we have to check those assumptions. That's the nice thing about the pilot. It gives you the opportunity to check the assumptions before you submit. Okay? So what I do is, how I do it is I'll sit down with individuals and say, okay, what are we doing? Teach your statistician, what is the research here? And if we're doing a pilot study, I want to be able to set it up where everybody is on the same page, that we're going to come up with confidence intervals for certain key things, and we're just going to come through and get descriptive statistics. And I will usually try to put the sample sizes of a pilot study pretty much down into the 30 to 50 person range. You really shouldn't be expecting mega stuff going much beyond that. Sometimes it can't even get above 12, but I've successfully used pilot studies of 12 to justify a future study. There's like a duplicate slide, sorry about that. Some examples of goals. And these are arbitrary, but I've seen these work. I mean, you want to be able to say that you want to have a 90% completion rate. That's what you're hoping for. And why do you put those numbers down? You put those numbers down as a benchmark to be able to say, if we're going to be successful, we need to be able to achieve this level of individuals completing the study. One of the key things we always assume is, in every power calculation, we inflate by what? 10%, because we're expecting dropout. in the pilot. The pilot gives you a good idea of how to estimate how many people are going to drop out. Gives you an idea. You also want to be able to say, what is the minimum, will people do the minimal amount that we would believe to say that they have sufficient data to be in the study? This is arbitrary, but in the study that we did years ago, we were hoping to have 85% of these elderly individuals to complete all of their weight training. But once we did that pilot, we said, look, this is the rate that people are going through. If they are completing these, we had the statistics that would appease or convince the study section. It's very important to set benchmarks. You've got to be able to have inside the pilot study what will convince you to go to the next level. If you write the whole thing, you say, I'm going to collect all this, but you never come out and say, if this type of evidence will make me convinced to go to the next level, then you're still weak. You're still lacking something. Once those benchmarks, you don't want to sandbag it too low. You don't want to put it too high either, but you want to keep it where things are getting done. And it's hard for me to talk about the actual benchmarks because I can't give them to you. Everybody comes to the statistician to get the power calculation. I never give you the power calculation until you give me the assumptions. And we have to sit down and discuss that. When we're designing a pilot study, you have to be able to give me the specific aims before I can give you the analysis plan. Same thing goes with regard to the benchmarks. You have to come to me and say, these are the benchmarks I would like. Then we'll talk about how can we measure those benchmarks and what, by your clinical opinion, do you think a reasonable level of that benchmark should be? So it's an ongoing discussion. There it goes again, something went wrong with slides. So we're winding down near the end. That's the other thing to keep. Yes, sir.
Could you give an example of a benchmark?
A benchmark would be, again, one of those things where we would hope to have for the diary. If we're doing a 7-day diary and we have allowed 50 individuals to come through the pilot study, we would want to have 40 of them to have complete 7-day records. So the diaries are usable at that point. So that type of benchmark. And then what I would do from there, I would take those 40 individuals who had completed it, use that to calculate standard deviations, descriptive statistics, get very basic charts that can be included into the larger grant, go from there, use that standard deviation for the power calculation. Okay? Great question that always comes up, and it is very simple. May I include my pilot data into my larger study? The answer, I'm not trying to be on the fence, maybe. I wish I could tell you definitively yes, but it may not be true. And I don't like misleading people. If the appropriate statistical methods are used in the larger trial, in other words, if you have set your power calculation up and you've got a certain way in, and you've got all the techniques are called internal pilots, but you get a certain way in, you say, okay, I'm going to now estimate the standard deviation to see if it was anywhere close. If you say, I'm not changing anything, I'm just going on, more than likely you'll be able to use your data without too much consequence. However, if you have to adjust that sample size up, you've got to account for that in your next study, or if you're really bold and adjust your sample size down, you still have to account for it. The answer is yes, with caution. That's why I said maybe. The other thing to keep in mind, if you get at the end of your pilot and you decide I need to refine, you've got everybody that you're able to randomize, you're able to consent, you're able to do a lot of things that you wanted to do. However, you feel like you need to revise your forms. Now what are you going to do with your pilot data? Can you squeeze that into your larger grant? Probably not. Once you start messing or changing your forms, you have to be very careful. You want to have all the data on all the subjects. So it's one of the things you monitor as you go through the study. Can I randomize in a pilot study? Absolutely. I got blown away earlier this year. Somebody said, well, I'm not going to submit the pilot for the CCTS. I said, why not? Well, I really need to randomize. And I just had this really baffled look on my face, like, and why is that a problem? There's no reason not to randomize. You might have to be able to demonstrate. You know, think about this. You know, sometimes when you go to tell people that you're going to randomize, people withdraw. People don't want to do this because they don't want to have random assignments. So you have the ability to consent and the willingness to accept random assignment are actually reasonable goals within a pilot study. So if you feel like you're going to end up doing a 2-arm study, you're going to compare diet A to diet B, or you're going to compare different things, I would go ahead and put the randomization in the pilot study to demonstrate that they would do it, and then to test both the diets and the adherence to both the diets. Keep in mind, you want to test drive your future study as far as you can. It's a good analogy. It's like test driving a car. You want to keep the car as long as you can so you know it as much about it as you can. You want to test drive your future study. Design it as best you can. Collect a small amount of information. Go from there. Refine as early as you can. All right? Now, here's the big bugaboo, okay? This is where I get really worried about people doing pilot studies. And I'm going to put my foot down. Size 11. If I randomize, so I'm going to be able to calculate the difference between 2 arms, can I use results of my pilot trial to estimate a treatment difference and use that for power calculation? In other words, can I take all my information and just use that to give me a power calculation? You can read, I know. Absolutely not. Never. No. Will not agree. I will be stubborn. Sorry. And you're going to say, why, David? Why are you so adamant about that? The pilot study is designed to help me as a statistician get the nuisance parameter. The piece that I need to know to get the power calculation correct or as accurate as I can, but it is not to override clinical opinion ever. So this is the idea. The pilot study gives me the estimates of the standard deviation. How noisy is the data? How noisy is it? That's key for me. At equal importance is what does the clinician define as the minimum clinically relevant difference? What is the smallest difference that matters to a clinician? If you define that from the data, if you go to the data to make that judgment, the tail wags the dog. The wrong way. You need to be able to have the clinician's opinion define the term you used, the effect size. The effect size has 2 key components, the variance and the difference that you are expecting between 2 arms. I think the difference should always be based upon clinical opinion, not on preliminary data. Okay? The variance estimates can be estimated from the data. All right? So now I'm going to do some shameless puff plugs, and I'm going to let you have some time back a little bit early. Keep in mind that I am a member of the CCTS BERD, and twice a week we have walk-in clinics. So if you are thinking about doing something like a pilot study, or if you need to be able to you've got some calculations or some databases that you need some analyses or graphs built for a future submission of a grant or a manuscript, we are there twice a week. One time it's over at the Edge of Chaos every Monday, 10 to 2. And then the second weekly clinic is Wednesday right here with lunch, 11:30 to 1. Okay? Hey, lunch is important. The walk-in clinics are really ideal for what I would call simple analysis advice, or if you have the data set, they'll have the software here, and try to go from there. Also, some rudimentary power calculations. If you're doing a 2-sample t-test, or you're doing from NOVA, something along those lines, we can probably sketch that out within the clinic, no problems. But also keep in mind as you're going for bigger things, such as any R mechanism, or if you're going to go after a K award, we are always available for one-on-one consultations with that. Okay? So those services are available to anyone on this campus at any time. How do you do it? You don't call me. I don't mean that bad. I know that sounds almost crass, but there's a reason to go through the research commons. And you have the email, to make certain that you get it when we also send out those papers. It's a matter of organization. If everybody tries to go to different individuals, nobody can figure out who all's doing what. If we funnel it through one point, we're able to distribute it out. So that's why we ask you to come through research commons. But we'll be there, when you're ready to do your pilot, when you're ready to do your R, when you're ready to do your K, we're here to help. Okay, and that is it. Any questions? Wow, no questions.
Unmute.
Nothing unmuted, sorry.
I have a question.
Okay. Yes, Amy, what do you have?
On pilots, they usually want to test the feasibility and acceptability of the project. So when you test the feasibility, you're doing like recruitment consent. So what do you consider acceptability? Is that when you, the participants, I don't know, what would you consider?
What are you saying? Well, I would be very eager to know what people mean by acceptability. It's kind of like the word reproducibility. When I talk to people about reproducible science, everybody has a different definition. I'm not trying to avoid your question, but accessibility, I know, sometimes we are doing certain things and trying a new assay. I may be willing to guess that they're trying to do a new assay, and are we going to be able to achieve the precision and the measurements that you think we should be able to do? Are we done recording, David, yet?
No.
Oh. So here's one of those things that would have been nice.
Do you want me to cut it off? I don't know how.
Okay, well, then this will just go down on internet history. One of the things, there's a study that, my long list of studies